In this video, we're going to talk about calculating the empirical formula from experimental data. Basically, if we're given some sort of grams of any atom or element, rather, we got to decompose it together and create a molecular or an empirical formula for that compound. And so, I have this question here. It says, well, we decompose a sample of water and recover 0.857 grams of hydrogen and 6.86 grams of oxygen. What is the empirical formula? Well, anytime, it's given in this sense where you have grams of different elements and you need to come up with an empirical formula, what we do is that we find the moles of each element first, okay? So what does that mean? Well, if I take 0.857 grams of hydrogen, I'm just going to simply go to the moles. I'm simply going to go to the moles. And so if I take a look at my periodic table, I see that for every 1 mole of hydrogen, I get 1.008 grams. And so for every 1.008 grams of hydrogen, I get 1 mole of hydrogen. Okay. And so when I divide these two together, when I divide 0.857 by 1.008, I should get around 0.849 moles of hydrogen. Okay. Now I have to do the same thing for oxygen. So if I look at this, well, I have 6.86 grams of oxygen. Okay, and that is true. Well, I need to go to moles. So for every 1 mole of oxygen, if I take a look at my periodic table, I see that for every 1 mole of oxygen, I get approximately 16.0 grams. And so my 16.0 grams will go on the bottom. Grams will cancel grams of oxygen. Okay. And if I simply divide 6.86 by 16, I'm going to get approximately 0.429 moles of oxygen. Okay. Now, once or elements are converted into moles, we look at the one that gives us the lowest number, and then we divide both the moles. Well, in this case, because we have 2, we're going to divide, but if it was 3, 4, whatever, the process is the same. What I'm going to do is look at which number is the smallest. I'm going to take the smallest number and divide all the moles by that to give me how many actual elements, how many of the elements do I have? So what do I mean? Well, let's take a look. I'm going to take 0.849 moles of hydrogen. And remember, this is the smallest number of moles, okay? And well, I'm not even going to take the moles of hydrogen. Let's see what the unit. So I'm going to take 0.849. I'm going to divide it by the smallest number, which is 0.429. Okay. And when I divide that, I'm going to get about 1.98. Okay. I'm going to get about 1.9. I'm going to get about 1.98. Okay. And because we're dealing with hydrogen, and let's put in back the units, well, it's moles of hydrogen. Because we're dealing with moles of hydrogen, 1.28, we can't have 1.28 of an element. And so this is rounded up to 2. So in fact, we have 2 moles of hydrogen. Okay. Now I'm going to do the same thing for oxygen. I'm going to take the 0.429 moles of oxygen. I'm going to divide that by, obviously, 0.429. Okay, when I divide that, you can see that I have approximately 1 mole of oxygen. Okay, so all I did was take the smallest number of the moles and then divide both these numbers by that number, okay, to get how much of the element do I actually have. And then you can see that I have 2 moles of hydrogen, 1 mole of oxygen. Empirical formula in this case would be H2O. Okay, so this is a process of how you go about calculating the empirical formula from experimental data.